See this problem. In an AC circuit, a condenser, a resistor and a pure inductor are connected in series across an alternator. If the voltage across them are 20 volts, 35 volts and 20 volts respectively, find the voltage supplied by the alternator. Now our motto is we need to find out the voltage for the whole circuit. So condenser, that means a capacitor is given, and a resistor and a inductor are connected in series with an alternator or generator like this. So, and the potential drops over there also given, that is 20 volts, 35 volts and 20 volts at respective elements, and voltage, the total voltage we need to find out, that is the motto. Now we will resolve. So while resolving we have two solutions. I will explain both. The first one is, look at that given data. So first of all I will write I will find the investigation. In the investigation, the VC, voltage at capacitance or condenser, is equal to 20 volts and VR is equal to 35 volts and VL, that is equal to 20 volts. So I am resolving right now. So while resolving we have two solutions. First one I will explain. So solution 1. So if you see, VC is equal to VL. So VC is VL, and one more, the whole circuit is in series. That means current passing through all these devices is same. So if we write like VC, if VC is equal to VL, then I can write I into XC, I into XL. Assume that I is the current flowing through that circuit. So at every element the current is same, so I gets cancelled. XC is equal to XL. That means the inductive reactance and capacitive reactance are same. So but this will be possible only at a resonant condition. So this is a resonant condition. That means the total resistance offered by a circuit is R itself. So that means Z is equal to R. So V is equal to IZ, that is equal to IR, that is equal to 35 volts itself. That's all. This is one solution, and I'll go for another solution, solution 2. So according to phasor diagram also we can write phasor diagram, so if this is the voltage at resistance and this is the voltage at capacitor and this is the voltage at inductor, according to the phasor diagram the total voltage is equal to, the square of the total voltage is equal to square of the voltage at resistance plus VC minus VL whole square. According to phasor diagram we can write the potentials of respective elements with this formula. We can relate those potentials with this formula. Or V is equal to root of VR square plus VC minus VL whole square. So from the given data VC is equal to VL, so these component will be rid of. Then V is equal to VR, which is equal to 35 volts. So that is the consequence of this problem. So after whenever the potential at capacitor and potential at inductor are going to be equal, that means the circuit is at resonance. So at that moment the resistance offered by circuit is itself is the main resistance in the circuit, and the potential of the total circuit is the potential drop at the resistor.